Okay, continuing on with the Algebra 2 extra practice packet number 7 deals with synthetic division. So if I want to divide 2x to the third minus 13x squared plus 26x minus 24 by x minus 4. So this is where we make our little L thing here. So our coefficients 2, negative 13, 26, negative 24. And then we put the opposite of this on the outside, so the opposite of negative 4 is positive 4. Bring the first one down, so it's 2. Multiply 4 times 2 is 8. Then add, that's negative 5. Then multiply, so it's negative 20. Then add, that's positive 6. Then multiply, and that's positive 24. Add, you get 0. Remember, the last number is your remainder, if there is one. So my answer would be 2x, and again we always start one less than we started with, so squared, minus 5x plus 6. Okay, number 8 is divide by factoring. So I want to divide x squared minus 5x minus 14 divided by x squared minus 3x minus 28. So we're going to do a diamond problem with the top. So we'd have negative 14 on top, negative 5 on the bottom. So our two numbers that multiply to get negative 14 and add to get negative 5 are negative 7 and 2. So far on top I got x minus 7, x plus 2. On bottom, I'd have negative 28 on my diamond on top and negative 3 on the bottom, which that would be negative 7 and 4, because negative 7 times 4 is negative 28, negative 7 plus 4 is negative 3. So I'd have x minus 7, x plus 4. Then again, if they're the same on top and bottom, they cancel. So I can cancel out your x minus 7s, and I'm left with x plus 2 over x plus 4. Okay, number 9 dealt with simplifying square roots. I know normally I put exponents with them, but I didn't on the extra practice. So I'm just going to do part B on this one, so 98. So we start by breaking it down by whatever you know that goes into it. So I know 2 goes into it, so I could take square root of 2, and 98 divided by 2 is 49. And then I know 49 could break down to 7 and 7. So again, once you get down to all prime numbers on the bottom, you look for pairs. So I have a pair of square root of 7s, so it'd be 7, and then I have a square root of 2 left over. Okay, 10 were square root operations, either multiplying or adding and subtracting. So I'll look at part B here. When you're adding or subtracting, you have to make sure these square roots are the same, just like terms. So 10 square root of 2 minus 4 square root of 2 is 6 square root of 2. Okay, number 11 was solving radical equations. And when you're solving radical equations, you need to do the opposite. So I'll look at B here. The opposite of a square root is squaring both sides. So when you square a square root, you're left with what's just on the inside. So if I square the square root of 3x minus 9, I'm just left with 3x minus 9. 6 squared is 36. So then it's just a two-step equation. So add 9, 3x equals 45, divide by 3, x equals 15. 12 was on adding rational expressions. So we kind of did this the butterfly method, so it's fine. So the butterfly method says we'll take 3 times 5x, which is 15x. And we'll take 2 times x, which is 2x. And then we'll add those together. So 15x plus 2x is 17x. And then on the bottom here, we'll multiply those together. So x times 5x is 5x squared, and then we'll simplify. So since this is like x to the first on top and x squared on bottom, I can cancel out one of the x's. So that gets rid of all of them on top, but still leaves me with one on the bottom. Okay, 13 we were understanding the basic logs. I'll do C on this one. So we understood that this was the base taken to the outside power equals what we were taking the log of. So in this case, 3 to the x equals 81. So we're trying to figure out what power of 3 gives you 81. So if you wanted to, you could go, well, 3 times 3, so that's to the power of 2, and then keep on multiplying by 3 until you get 81. So that's 3 to the second. If I do another 3, that's 3 to the third. Another 3 gives me 81, so that means x would have had to have been 4. Okay, 14 was adding or subtracting matrices. So again, you're just going to add or subtract the ones that are in the corresponding parts. So this would be 14 minus negative 4. So minus a negative makes that plus 4. So 14 plus 4 is 18. Negative 9 minus 18 is negative 27. 26 minus negative 9. Again, this is going to turn that into a positive 9. So 26 plus 9 is 35. And then negative 3 minus negative 16. Again, negative negative makes that a positive 16. So negative 3 plus 16 is 13. "15 dealt with scalar multiplication, which basically just means we take the outside number and multiply it by all of them, kind of like distributive property. So 7 times 16 is 112. 7 times 22 is 154. 7 times negative 14 is negative 98. And 7 times negative 20 is negative 140. "16 was on mean, median, and mode. So again, the mode is the one that occurs most often, which if you look at this data, there's 2 5s, so that'd be 5. The mean is where you add them all up and divide by how many there are. So I have 5 plus 8 plus 9 plus 11 plus 13 plus 3 plus 5 plus 19 plus 21. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be 10.4 is fine. The median's the number in the middle if they're in order. So if I put these in order, my smallest number I have is 3. And then I have 2 5s. Then it looks like 8, 9, 11, 13, and then 19 and 21. So since there's 9 numbers, our fifth number is going to be our median. So 1, 2, 3, 4, 5. So the median's 9. 17 deals with experimental probability. So if I look at part B in this one, find the experimental probability of flipping a coin and getting tails if you have gotten heads 18 out of 31. So if I've gotten heads 18 out of 31, that means I've gotten tails 13 out of 31. So I would take 13 divided by 31, and that would give me 0.419 approximately. And we can just round these to the nearest tenth, so that'd be 41.9%. Okay, on 18. So we're trying to find theoretical probability here, so I'll do part C. Find the theoretical probability of drawing a jack, ace, or king from a standard deck of cards. So there's a jack, ace, and king, so there's 4 suits. So there's going to be 4 jacks, 4 aces, 4 kings, so that's 12 cards out of 52. So if I take 12 divided by 52, I get 231 approximately. So about 23.1% would be your probability. If we look at part B in this one, I was on the fundamental counting principle. So each question on a 5-question multiple choice quiz has answer choices labeled A, B, C, D. How many different ways can a student answer the 5 questions? So we got 5 questions, and there's 4 choices for each question, so I can answer the first question 4 ways, second 4 ways, and so on. So it'd be 4 times 4 times 4 times 4 times 4, which is 1,024. And then part B, or number 20, part B on basic permutations. A newspaper has 9 reporters available to cover 4 different stories. How many, should say many, how many ways can the reporters be assigned? So we've got 4 different stories. So I've got 9 reporters I could choose for the first one, 8 for the second one, 7 for the third one, and 6 for the fourth one. So if we take 9 times 8 times 7 times 6, which is 3,024. So that's how many different ways those reporters could be assigned.